Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nur Iman bin Sulaiman.
Okay, my name is Muhammad Dinul Hakim bin Muhammad Yusuf.
My name is Muhammad Jawata.
For the assignment, our group has chosen Intel 8085 microprocessor as our microcontroller. Firstly, I explain the architecture of this microprocessor. This microprocessor is pronounced as 8085 microprocessor. It is an 8-bit microprocessor designed by Intel in 1977 using NMOS technology. This microprocessor has following configuration such as 8-bit data bus, 60-bit address bus which can address up to 64 KB, a 60-bit program counter and a 60-bit stack pointer. It also has 6 8-bit registers arranged in pairs such as BC, DE, and HL. This microprocessor requires 5-volt supply to operate the 3.2 MHz single phase clock. Okay, next I will explain the functional units for this microprocessor. This microprocessor has several functional units such as accumulator. It is an 8-bit register used to perform arithmetic, logical, input-output, and load and store operation. It is connected to the internal data bus and ALU. ALU is arithmetic and logic unit. It performs arithmetic and logical operation like addition, subtraction, and or others on 8-bit data. Microprocessor 8085 also has general purpose register. There are 6 general purpose registers in 8085 processor such as B, C, D, E, H, and L. Each register can hold 8-bit data. This register can work in pair to hold 16-bit data, and their pairing combination is like B and C, D and E, or H and L. Next, the program counter for this microprocessor is a 60-bit register used to store the memory address location of the next instruction to be executed. Microprocessor increments the program whenever the instruction is being executed, so that the program count points to the memory address of the next instruction that is going to be the next executed. Lastly, stack pointer for functional unit, it also has 60-bit register work like stack, which is always increment or decrement by 2 during push and pop operation. This is the figure of 8085 architecture. For interrupt in 8085 microprocessor, interrupts are the signals generated by the external device to request the microprocessor to perform a task. There are 5 internal interrupt signals such as trap, RST 7.5, RST 6.5, RST 5.5, and INTR. Interrupts are classified into following group based on their parameter. First, the vector interrupt. In this type of interrupt, the interrupt address is known to the processor, for example, RST 7.5, RST 6.5, RST 5.5, and track. Secondly, for non-vector interrupt, this is the type of interrupt that the address is not known to the processor, so the interrupt address needs to be sent externally by the device to perform interrupt, for example, INTR. Third, maskable interrupt. In this type of interrupt, we can disable the interrupt by writing some instruction into the program. For example, RST 7.5, RST 6.5, and RST 5.5. For non-maskable interrupt, we cannot disable the interrupt by writing some interrupt into the program. For example, like a trap. And the second last is software interrupt. In this type of interrupt, the programmer has to add the instruction to the program to execute the interrupt. There are 6 software interrupt in 8085. Example, RST0, RST1, RST2, 3, 4, 5, 6, and 7. And lastly, for the interrupt in microprocessor is hardware interrupt. There are 5 interrupt pins in 8085 used as hardware interrupt. Example like trap, RST 7.5, RST 6.5, RST 5.5, and INTA. That's all for my part. Next, I will give to my partner.
PWM in 8085 microprocessor. The microprocessor has created a significant impact in its various fields. The availability of low cost, low power, and small weight computing capability allows the user to use it in different applications. Nowadays, a microprocessor-based system are used in automatic testing product, speed control of motors, traffic light control of furnaces, moving message display, etc. One of the important applications is waveform generator. There are 4 types of waveform generator: sawtooth waveform, positive ramp, sawtooth waveform, negative ramp, square wave, and triangular wave. So this is the application of sawtooth waveform, positive ramp. So we can see the waveform for sawtooth and the program description of the sawtooth waveform. And then there is sawtooth waveform, negative ramp waveform, and the program. And then the triangular waveform and the program. And lastly, the square waveform, positive ramp. Next is interfacing analog to digital converter with 8085 microprocessor. The ADC for 8085 follow the initial 3 steps of interfacing of 8255 with 8085 are given before. The ADC A080 is a channel 8-bit ADC chip. It has 8 analog inputs. One of the channel is selected by sending address to address line of ADC. The logic level and selected channel is as shown. Next is the analog signal is connected in channel 3. The digital equivalent data D0 until D7 is connected to PA0 until PA7 of port A. The PC0, PC1, and PC2 lines of port C are connected to channel select address line of 8255. PC3 is connected to SOC, start of conversion, and ALE signal, input signal. EOC, end of conversion, which is an output signal of 8255 connected to PC7 of port C. The PB0 of port B is connected to OE, output enabled input signal of ADC. The control word format for above interface is given. That data from channel selection, a high to low signal is applied for obtaining data from ADC. These are the data shown. And then this is the ADC interfacing diagram.
And I will talk about I/O rehubs in microprocessor. Microprocessor rehubs provide the communication between microprocessor and the outside world. It is the main part that facilitates the operation of microprocessor. That rehubs are exciting in many types such as GPIO, I2C, SPI, UART, timers, and USB. Input and output rehubs of 8085 microprocessor is one type of interference technology that used in 8085. Microprocessor interference is connected to microprocessor virus, perhaps that used to exchange information with other devices and to obtain an output. There is 2 types of microprocessor interference: I/O interference, memory interference. In memory interface of the 8085, the microprocessor has 16 address line and 64 KB of memory location that can be used to save data. The I/O pre-hubs interference are different from memory chip interference. It involves in controlling signal I/O read IOR and I/O write IOW, where they use two active input and output devices. Identify input and output devices with address and data transferring. WR writing command and RD reading command. The MEMW and MEMR are for memory interference. Read and write. Input operation happen between a comparator and input device, same as output operation also happen between accumulator and output device. In instruction used to access the input device, it has 2-byte instruction and 8-bit format, and out instruction used to access the output device also has a 2-byte instruction and 8-bit format. In the I/O interference, the address is 8-bit, in which start from A0 to A7 or A8 to A15. The lines are used to generate the device address. The instruction is either in or out. Maximum number of I/O devices are 265.
Application of microcontroller Intel 8085. Okay, first, microprocessor is designed for small and dedicated applications, but gradually they are used in variety of applications from small household to large applications. So they include day-to-day applicable equipments like gaming console, DVD players, television, tools of car, test instruments, light dimmers, smoke alarms, hi-fi audio-visual components, credit card processing system. Also, it is used in communication systems like digital telephone sets, satellite communication system, radar system. It is also used in various medical devices like ECG, electrocardiogram, EEG, electroencephalogram, and ultrasound machine alcometer. So some applications require powerful low-cost microprocessors, and some having costly, complex one. Usually non-programmable controls would require bulky, costly, and complex implementation to obtain the results possible with microprocessor. Okay, for example, microprocessors are also used in various gaming consoles or DVD player. And another example, microprocessors are being used in a wide range of communication equipments like in digital telephone sets, telephone exchange, in television, and satellite communication. That's all.